This begins chapter 22, which is conditional execution. This is the first of 3 chapters which are going to be devoted to programming in R. R is both a programming language and a statistical language and a graphics language. It can do a lot of different things. It's very versatile. And this is kind of more of an advanced topic compared to what we have done earlier. The title conditional execution in the context of R could have also been called the if statement, because that's what we are going to cover is the if statement. Here are the programming subtopics. The first 2 are general, and then the next 3 are going to be specific to R. The first is how to design an algorithm, and we'll talk a little bit about that in some of the videos that are upcoming. And the second is a D chart. How is it that you plan to execute a particular algorithm? And one way of doing that before starting to code is putting together a D chart. The 3 topics that are going to be hit, first of all, conditional execution will be covered in this chapter. Those are if statements. The second topic will be covered in chapter 23, and that's iteration or looping. And the 2 most common loops that are used in R are the while loop and the for loop. And then a third topic will be covered in chapter 24, and that is recursion. And a recursive formula is a recursive function is a function that can call itself. So here's the syntax. If some condition is true, then you put a statement right there. So if there's only one thing you have to do if a condition is met, then this is the simplest form of the if statement. A second way of doing this is if condition, then do one statement, but if the condition is not met, then do another statement. That's still another form of the if statement. Here's one that you probably won't see quite as often: if condition, then statements. You could put a number of statements in the curly braces here. You could separate them with semicolons, but that typically isn't used because it makes for a very long line. The same is true of this. If condition, then do these statements. If the condition is not met, then do these statements. The usual syntax that we're going to be using is if there are multiple statements, then what you can say is you can say if some condition is true, you put in a curly brace, and then you have as many statements as you need to execute if the condition is met. And then else, and again, this else can go on a separate line. That's another possibility, but I'm including it on this line just in case you're in the console typing things in. You don't want to have this initial curly brace, this one right here, because that will end the if condition. So that's why I put the else on the same line here. Otherwise, you do these statements right here and then close all of it with a closing curly brace. This type of thinking you have already seen when we hit the if-else statement in an earlier chapter. Here is a little bit of information on the condition. First of all, the condition is a single logical value, and by that I mean a vector of length 1, or if the condition happens to be a numeric, then 0 is interpreted as false and non-zero is interpreted as true. Usually, you're going to have a logical value in there as a condition. Finally, and you have seen this in the last video where we did the exploratory data analysis function named EDA, you always want to indent your statements that are within an if statement. And you can see those 2 indented values are right here. This will be automatically done for you in the upper left-hand window, which is helpful when you're writing functions. I'm going to shrink this a little bit because we'll do our programming up in this upper section here. But let's start out with the following. Let's create a function called my.abs. So my.abs And this will be our own absolute value function. There's nothing wrong with the absolute function that's built into R. It's going to be much better than what we're going to build here, but I'm going to show you that you can build your own with if statements. So this will be a function of x, and what we would like to do in here, first of all, is ask the question, is the argument x negative? So let's ask that. If the argument x is less than 0, well, what do we want to do if that's the case? What we would like to do is we would like to replace x by minus x, and at that point we will return whatever is in x. We have forced it to be non-negative by doing that, and we're done. So once again, I'm going to highlight all of this, push run. When I push run, it will be executed down below here, and we didn't get any errors, so that's a good sign. Let's test my.abs with a number of different possibilities. Let's try my.absolute value of -3 and my absolute value of 0, and let's try a positive value to make sure it doesn't mess that up. Let's execute those just to see how they go. So it executed all of those, and they seem to work pretty well. The absolute value function, when fed a -3, gives you a +3. The absolute value returns 0 when it gets a 0, and the 12 is untouched. So apparently this if statement is working just fine. Try another example. Let's this time give it a vector. Let's have it do -2, 0, 3, and -17. Let's see how it does on those. And highlight everything, push run, and you can see when it gets to that last one, it fails. There's a warning message that says, in the if statement, x less than 0, x equals -x, the condition has length 1, and only the first element will be used. So the problem here is you see that it only took the first condition. When it got to this x less than 0, what it did was it said x here is a vector of length 4, and there it is, and 0 is a vector of length 1. And even with recycling, if it came back with a vector of length 4, it's looking for a single logical, not 4 logicals, and so it's complaining down below saying, look, I'm only going to apply this to the first element. Well, the first element is -2. It got changed to +2, but our -17, oh, I'm sorry, it actually applied that negative to everybody, didn't it? Right? When it went from here as an input down to here, it negated everybody, and that's not what we want to do. We want to negate them one element at a time. So what we're going to do is we're going to try to work with my.absolute value and see if we can fix it so that it will work for a vector. So the first thing we're going to do is we're going to take this if statement right here and we're going to replace it with the following. We are going to say x sub x less than 0. That is, for all of the indices associated with x less than 0, what we want to do is return the opposite of x for those particular indices. Now, this is not the most efficient programming. I probably should have taken this x less than 0 and computed that just once rather than twice. But in any case, let's see if this works. So we'll highlight the whole thing and click Run. And in this case, we can go up a little bit. You can see it worked fine on -3. It worked fine on 0. Worked fine on 12. And in addition, it worked fine on the vector. So sometimes you can work with these functions to get them to work on vectors as well. Let's try another one. my.absolute value, and let's put a string in here like hello. Now that doesn't make any sense, because what is the absolute value function going to do with a string like hello? Let's push run, and you can see it will actually tell you there is an error here somewhere. This is an invalid argument to a unary operator, and the unary operator that it's talking about is the less than. It does not know how to take a string and compare it to 0. This is what we get into in the world of what's known as defensive programming, and we're going to do some error trapping here. So I'm going to go up and add to my.absolute value, and we're going to put an error trapping condition up top. And we're going to say if the mode of x is not numeric, then what we want to do is we want to print an error message. But even better than just printing an error message, there is something called stop. And this will print whatever I put here. And I'm just going to say non-numeric argument. And that will stop execution. And it'll never get down to the next step to see what happens there. So once again, I'm going to move this up a tiny bit. There we go. I will highlight this top part and push run, and let's see what we get. So works fine on the first one, fine on the second, fine on the third, fine on that one. For some reason, the mode of x, oh, in this case, it will print the words error in my.absolute value. There it's saying non-numeric argument, and that's exactly what we got up here. So that's known as error trapping, and you can see that's a little bit different than what we got here, which is invalid argument to unary operator. It turns out our error message right here is going to be a little more clear to a user. So that's an example of writing a function that contains the if statement, and this is a special case of conditional execution, and the next video will contain still another example.